Okay, we have a question that says we should prove that log 125 over log of 25 is equals to 1.5. So what we want to do is what we want to prove, we will solve this side, and if we are able to get this one, and that means we are able to prove it. Now, how do we show now? How do we prove this explanation? We have log 125 over log 25. Now, don't make the mistake of using this one to cut this one. Don't need everything. So we can transform this one as well. Log 5 raised to the power 3. 5 raised to the power 3 is 25. And then this one will be log 5 raised to the power 2. And from our loss now, we can put all these ones to the back. We say log 3, 5, and then 2 here too. Log 5. So from here, this one and this one can cut. So what we have left is 3 over 2, and 3 over 2 is 1.5. That is proof. Okay. This is another question that says we should solve 2 raised to the power x equals to 5, giving our answer in 3 significant figures. We solve 2 raised to the power x equals to 5, giving our answer in 3 significant figures. If you look at this particular question here, there's nothing we can do when it comes to indices to solve this particular one, because 5 cannot be broken down into 2 raised to the power something. So the best thing we can do now is to take logarithm of both sides. So when we take it like this, we have log of 2 raised to the power x equals to log of 5. So now, what do we have now? From here, we can move this one back. We have x log of 2 equals to log of 5. Just move this x back here. So we have x log 2. So now, what do? We can divide both sides by log 2, log 2, so that this one and this one cut each other. So we have x equals to log 5 over log 2. And what can we do to this? Log of 5. Let us use our calculator to check that. Log 5 is 0.69897 over log 2 now. Log 2 equal to log 2 is 0.10. So now we have to divide the two of them. So we have 0.69897 divided by 0.3010. So our answer is 2.322, and therefore x, which is equals to, now if you look at this one now, this one is 5 significant figures. They ask us to leave our answer in 3 significant figures. 1, 2, 3. So we approximate this one, and that's plus 0, because this one is not 5. So we have 2.32. 2.32. That's the answer to this question. Thank you. Okay. We have another question on the board that says solve log to the base of 3 of x plus 2 minus log to the base of 3 of x equals to log to the base of 3 of 8. Now, one major thing that you have to first notice here is all of them, they are in the same base. So since they have the same base now, so you don't really have much problem like that. So the major thing that we need to do is to transform this one based on some of the logs that we have learned before. And this one, we can rewrite this one as log to the base 3 of x plus 2 over x equals to log into base 3 of 8. What we have is this, log into base 3 of this, because this one is a minus, so we can say this one divided by this one. And that's our second row, which is equal to this. So having gotten to this this level, so what we need to do is we can cut out to this side so that we can solve this one. So what we have now is we have x plus 2 over x equal to 8. So I think we can do cross multiply now. Cross multiply. That's this times this like this. So what do we have here? 8 multiplied by x now. That's we have 8 times x, which is equals to x plus 2 times 1. That's x plus 2. So now what do we have now? We have to collect like terms. So we have it answered as 8x equal to x plus 2. So bring this one here. So we have 8x minus x equal to 2. So we transfer x here. So 8x minus x, that will be 7x, which is equals to 2. And at this level, what are we going to do? We divide both sides by 7, which is the coefficient of x here, because that is what we are looking for. We are looking for the log of x. So 7, so x equals to 2 over 7. And that's our final answer. Okay? Alright, we have another question, another example, my brother says log into the base of 10 of 2x minus 40 equals to 3. Now, what we need to do here, solution, is you can see that we have log on this side, but we don't have log on this side. So how can we transform this number to log that will still have the same base? Now, anytime you have something like this, now you have log on one side and you don't have log on the other. Just look at this log here. You write it as log 10. So you now just put 10 here again of this power. Because when you take this one to the back now, what you have is log 10, 10, 10. 10 of 10 is 1. 3 times 1 is 3. That's why it is like this. So you have to look at, pay attention to the base, this log. Just write it like that. And then just put 10. This one. So let's say the base of this particular one is 3. Let's say it's 3. Let's say it's base 3. So this one will not be 3 again. Just write log base 3. Because it's 3 now, just write 3 of this 3. So when you bring this one down, you have 3 log 3, 3. Log 3, 3 is 1. 3 times 3 is 1. So, but this one now is 10. So I just need to show you how to transform numbers like that to logarithm. Now, how do we solve this one further? We have 40 equal to half. We just explain how to transform this number to 10. So that will be log 10 times to the power 3. Anything that is here must be here too. Just put this number on top of it. Take this one, and anything that is here must be here. Take that one as the power. So now what we have now is this one and this one we cut out. So we have what? 2x minus 40 equals to 10 to the power 3. So we have 2x equals to 2x minus 40 equal to 10 to the power 3 is 1000. So we have to transfer this one here. We are collecting, collect like times So now what we have now is 2x equals to 1000 plus 40, because when you move 40 to this side now, this side will change to positive. So we have 2x equals to 1040, and how do we get our x? We divide both sides by 2. So 2 cancel 2. So x equals to 2 here 1, 2 here 5, 2 here 2, and 0. That is 520. So the value of x that will be there, that will give us that particular answer is 520. 520. 520. And then if you put 520, let us see what we are going to get from that. Let us see. Let's call it check. 520, let us put it here, what are we going to get here? So we have log of 10, that's 2 times 520 minus 40. So what do we have? We have log 10, 2 multiplied by this, that is 1040 minus 40. So what we have now is log of 10, 1000. And we can transform it as log of 10, 1000 can be written as 10 raised to the power 3. So we move this one here, so we have 3 log of 3. So this one now is 1. So our answer is 3 times 1, which is equal to 3. That means our answer is correct. So we just use this one to check whether the answer we got now, you put it back, you will be able to get that. Thank you. Okay, we have another question under the same topic. We are going to be using quadratic approach to solve the question. Now the question is solve the quadratic equation this. So that is it now. So I demarcated the board because it's going to take some space. So now solution to this. So we write the question 2 raised to the power 2x minus 3 times 2 raised to the power x plus 2 equals to 0. Now the first thing that you need to look out for here is you look at the okay. We have 2 raised to the power 2x here, and we have 2 raised to the power x here. You can see that this one 2 raised to the power x, there's no number here with the x. So you have to pick that one and leave this one. So this particular one, we can rewrite it as 2 raised to the power x. I'll put 2 here. Because according to our law of indices, it says that when you have 2 powers like this, you can multiply together. So 2 times x now, we have 2x now. So we are not doing anything, we're just trying to restructure. Minus 3 times 2 raised to the power x plus 2 equal to 0. You can see now that I've been able to isolate 2 raised to the power x, even though we have 2 raised to the power 2x here. So when I say, okay, let p equals to 2 raised to the power x. So anywhere we see 2 raised to the power x, and I will put p there. So in this equation, I will put p. So we have p raised to the power 2. 2 raised to the power x is p here, and I put 2 here, minus 3 times, that's 3p, plus 2 equal to 0. Now let us solve it in quadratic way. So we multiply this one, that's what? 2p squared. So what we have now is, we are looking for 2 numbers that when we add it together, we must get minus 3p, and when we multiply it, we must get 2p squared. That is minus p minus 2p. Minus p minus 2p will give us this one, and when we multiply minus p minus 2p, we're going to get 2p squared, because minus times minus is plus. That is 1 times 2 here is 2, p times p is p squared. So we can come back here and say, okay, p squared minus p, putting this one minus 2p plus 2 equal to 0. What we are just doing is we are just substituting for this particular, because this is minus 3p, we just put it in. Then before you substitute now, the 2 numbers you must use must satisfy the 2 conditions. So that's why I have to bring the 2 of them like this now. So now, at this level now, let us bracket like this and factorize out. So what do we have now? I think p is common here. We have p minus 1. So what is common here? Minus 2. P minus 1, 2 equals to 0. Because if you open this bracket now, you're going to get this one back. So what do we have now? We take the one outside. So we have p minus 2 and then p minus 1 equals 0. So we have p minus 2 equals 0. That means p equals to, we'll transfer this one here. That's what? 2. P equals to 2. So if you put 2 here now, 2 minus 2 will give you 0. So p minus 1 also is equal to 0. If you transfer this one here now, that means p equals to 1. So we just got the values of the values for p. We have not gotten the value of x. So now recall that p equals to 2 raised to the power x. So you pick the first value. So you put it here. So 2 equals to 2 raised to the power x. Don't forget that these two now is raised to the power 1. So when you equate the power, so x equals to 1 here, because this one and this one will go. So for the second one, we have 1 here. So p equals to 2 raised to the power x. That is 1 equals to 2 raised to the power x. So this one I can transform it to 2 raised to the power 0. 2 raised to the power 0. That's x. Because 2 raised to the power 0 is 1. Any number raised to the power 0 is 1. But I have to use 2 raised to the power 0 because I have 2 raised to the power x. So if I equate the index 2 now, so x equals to 0. So therefore, we have two values for x. X equals to what? 0 and 1. Those are the two values of x for this particular equation to be equals to 0. Thank you. Okay, this is another form of quadratic equation question that we can still encounter under logarithm. Now, what do we have here? Solution. Now, I will see demarcate the board to the 2. So what we have here is 2 raised to the power 2x plus 1 minus 13 times 2 raised to the power x plus 20 equal to 0. Now, we need to try and manipulate this particular equation into 2 raised to the power x here. We want to try to isolate 2 raised to the power x out here. So this particular one, we can have 2 raised to the power 2x times 2 raised to the power 1. In indices, when we have things like this now, they have the same base number, we are going to have the power, that's 2x plus 1. That is what gives us this one. Minus 13 times 2 raised to the power x plus 20 equal to 0. Now, this particular one too, we can isolate it and say, okay, this is 2 raised to the power x, everything squared times 2, because 2 raised to the power 1 is 2, minus 13 times 2 raised to the power x plus 20 equal to 0. So at this level now, you can see that 2 raised to the power x has been isolated now. So we can now say, okay, let p equals to 2 raised to the power x. So we can now put it here now. So we have p squared, that is 2p squared. I put p here, that is p squared times 2, that's 2p squared, minus 13p plus 20 equal to 0. So let us take our quadratic 2p squared times 20, that is 40p squared. So let us take two numbers, minus 13p and then 40p squared. So what are those two numbers that when we multiply them together, we're going to get 40p squared, and when we add the two numbers together, we're going to get minus 13. I think 8 and 5. 8 and 5. 8 and 5 is a perfect number here. So minus 5p minus 8p. Minus 5p minus 8p will give us minus 13. Now, the best way to get all these things is you have to list down all the factors of 40. Numbers that you can multiply together. Two numbers that you can multiply together will give you 40. So The way I used to do is I say 40 equals to 1 times 40, 2 times 20, 4 times 10, 8 times 5. I think these are the numbers that we have now. So you now be adding it. Which one will give you minus 13? Which one? So if you add this one and this one, and that's 5, this one 22, this one 14, and this one 13. So that's why we have to go with this one. So now, let's clean this one. So what we have now is, let us write this one now. We have 2p squared. We'll substitute this one for this. We have minus 5p minus 8p and then plus 20 equal to 0. So let us capture it like this now and then factorize something else. Between this and this now, what is common here? What is common here is p. So we have p bracket, we have 2p minus 5. 2p minus 5. And then what is common here? I think 4 can go here, 4 can go here. 4 goes here, it has 2. So that will be minus 4 bracket 2p minus 5, which is equal to 0. So let us take the numbers outside. So we have p minus 4 and then 2p minus 5 equal to 0. So from here now we can say this p minus 4 equal to 0, therefore p equals to 4. So when we have this one now, 2p minus 5 equals to 0, we transfer this one now, we can say p equals to 5 over 2. Or you transfer this one to this side and you divide both sides by, what I did was 2p equals to 5. I move this one here. So I now divide both sides by 2. So I have p equals to 5 over 2. So now go back. Recall that our p is equals to 2 raised to the power x. So let us use the first value of p and then that's the second value of p. So 4 equals to 2 raised to the power x, and then we can transform this 4 to 2 raised to the power something. We have 2 raised to the power 2. After we have transformed it now, so we can equate like this now. So that means our x equals to 2 for this one.